Oops. You know what? I've been telling you to put this in B04. I should have checked Dropbox. It's actually B05. That's for all of them. I'll leave some notes around, trying to point out where things should go. I'm really sorry about this. It's data link layer. I should have checked that before starting. Okay, listen, I got one final thing I want to do before I send you off and say that we're finished with this section, and that has to do with that funny orange dot. Okay, so here, what I'm going to do, you don't need to actually try this, but like anything else, I certainly encourage you to actually take a look at it. Okay, here's what I'm going to do. I'm going to sort of move things around a little bit here, and we're going to pretend that we've got some slightly different things. I'm going to start by dropping out this link between here and here. All right, now so far I've got two switches and two completely separate things. Well, what if you needed more than, say, 50 computers? Could you have more switches? And the answer is yeah, absolutely. So what I'm going to do is I'm going to drag another switch here, I'm going to drag another switch here. Okay, and could I have different computers hooked up to these other switches? And yeah, absolutely. I could have another PC here with a connection onto this switch. So I'll put one into here. And I could easily have lots of things on the other side as well, but this is probably more than enough. Now, what I'm going to do is, well, for everybody to be able to talk to each other, here's what we would need to do. Oh, in fact, you know what? I'm going to actually configure this one. So, sorry, let's get into the desktop. I'm going to give this the address of 234.12.145. Okay, so now everything is connected. I could easily have one over here, and I want to, of course, be able to connect. Now, if I wanted to be able to reach from the upper left over to this new PC, somehow or another, I'm going to need to connect this switch one way or another. It doesn't really matter. Okay, I'll use one of these gigabit connections, and I'm going to throw a connection over here, and I'll use this one. Okay, and while I'm here, guess what? If I wanted to be able to connect from here down to this switch, I'm going to also provide this. Okay, great. Now, so what I've got is now everybody is connected because all the switches are connected. Okay, but now I'm going to introduce one extra line. What about if I make an extra connection from here and I plug it down to this one? In fact, what I'm going to do is let me completely ignore this one over here. Okay, sorry, delete this one because I don't need it. Okay, now let me hit fast forward time for a second. Okay, now if you take a look at my switch configuration, and those links between them. Okay, there we go, it's gone. You'll notice that I've actually got two ways of getting from the top switch to the bottom switch. I can either come directly or I could go over here to the edge through this other thing that is being called switch number 2. Now, clearly, if I open up this and I try to make a ping over to, now I've forgotten the IP address, so one second. This is why I do this type of thing. Okay, so let me take this, we'll copy, and I'll make a label over here and we'll paste this. Okay, that's the purpose of these labels so you can remember. Okay, let me pop open PC0 and let me try pinging 234.12.145. Well, you have to type it 200, not 300. Okay, 200. Oh, did I type? And again, I've made a silly mistake. Not 24, 34. Okay, here we go. So this is obviously working, and what happens is the broadcast packets go out here and they come down this line right here over to here. Now, if I still try to ping, say, number 12, sorry, 1222, before I get myself really confused. Okay, notice that I'm still getting it. How do the packets get there? Okay, well, obviously the packets start out here and they come down to this direction, but now the question is, does it come this way through switch 2 down to here, or does it come directly down here? Now, you might be saying, well, it must come directly down here because it would be faster. Okay, and yeah, that kind of is a reason why it's going. But the real reason is, take a look at this link. You'll see the link is showing green here and green here. Okay, and what that means is that is actually the link which is currently active. So that's how I get down to the bottom. In fact, if you wanted to, you could take a look at one of these PDU packets and you can actually send a message from here down to here and go over to the play, and you can actually let the thing run through. Okay, so you'll see the packet comes out here. It ends up being let's see, it should end up going down to the next part and then finally off to the actual machine. So you can actually see the traversal of the packets. So how come it doesn't go the other direction through switch 2? Well, it's because this link light right here is being marked as orange. So why on earth did they have one of these things? Okay, let me go back to my real time, let it finish. So first of all, why did we bother putting this in? Well, imagine if everything was green. What would happen? Okay, imagine the case of a broadcast packet where this computer wanted to send a message to the lower right hand corner. A broadcast message would come to here. What does a broadcast message do? Well, it sends it out to everybody. It sends it out to this switch and send it out to this switch. So what happens is this would send out that request, the ARP saying, who's got this address? It would come out to here. What would this computer do? Well, this would send it out to both places. Now, if this link wasn't blocked, then what would happen is the message would come down here and would broadcast to everybody, which would send a packet up to here, which would broadcast to everybody, which sends a packet over here, broadcasting to everybody, which would send a packet down here, broadcasting to everybody. So you can see this is obviously never going to actually get our packet all the way through. Now, the packet would make its way through, but there'd be so much traffic going in this little triangle, the packets would actually get lost. Okay, so that's the reason why this is being blocked. It's to remind the switch, okay, I'm here and available, but please don't use me. Now, the cool thing about this, watch this. If suppose I accidentally go with a pair of scissors or something else, I've seen this happen in doors. Suppose somebody comes and accidentally cuts this wire right here from switch 0 to switch 1. Take a look at what happens. Now, you might say that, well, now it looks like the bottom part of the network simply isn't available, but you know what? If you give this enough time, usually about 15-20 seconds, the link will actually come live again. Okay, and then suddenly everything would be here. Well, hey, since I'm on the clock here, I want to finish the video, you want me to finish the video, let me cheat and hit this fast forward time. You'll see that the link now actually comes up again. Okay, so you see what's happened is it has actually recovered the link back the other end. Okay, and likewise, well, let's put it back. So here we go. Let's plug it in from here down to here. Okay, over the two links, and again, we'll let the time go fast forward, and you'll see the link comes back. Well, again, the same thing could happen. Let's accidentally cut the link between switch 0 and switch 2, and take a look what happens. Okay, currently, this link is showing as being blocked because we're not supposed to be using it, but if we give it enough time, here we go. You'll see that the actual link does come back to being active again so that we can still reach all portions of our network. So this whole thing right here, these little orange lights, that is determined by something called spanning tree protocol. And what it is, it's something that runs in the background between the switches to make sure you haven't accidentally built up any loops so the packets would get lost. Okay, so generally we don't have to really worry about that in this course, but if you do connect something to a switch, you'll see the first thing it does, it takes a very long time. And what it's doing is it wants to check and make sure that no loops have actually been formed, and it wants to make sure that there is some way that you can actually route your packets. Okay, no need to do anything for this activity, but I certainly encourage you to try. In fact, if you want to try something, so I'll leave it as a fun exercise, why don't you configure about 7 or 8 switches and configure them all together with different paths and see whether or not you can kill off some of the things and see whether or not other links take over. So that's probably just like as a small practice. No need to submit anything for this particular lab activity, but as I said earlier, don't forget that you do have a quiz that needs to be finished. So I'm going to leave that with you. That is sort of officially the end of Lab B05. So hopefully you've gained something by watching these videos. Let me know whether or not the pace is okay, and of course if you have any problems doing any of the videos, send me an email, send me a screenshot about what you're up to, and we'll see whether or not we can help you out remotely. Okay, so see you in the next set of video lessons.